Welcome to Chapter 5.5a lesson video. We're going to talk about solving some equations, some exponential equations, but they're going to all have the same base. So these are going to be equations where two exponents are equal, and we're going to make them have the same base or find a way to make them have the same base so that way we can solve them. So let's go ahead and get started. So the goal today is to be able to solve exponential equations in this form, mostly ones with common base. All right, so let's just review a couple little exponent rules real quick. Some things I just want to make sure that you are familiar with before we get too far involved. Basic exponent rule says 2 to the 4th power means 2 times 2 times 2 times 2, and 2 to the 4th power would be 16. All right, 3 to the negative 3rd power, if you remember, the negative exponent causes us to reciprocate. So this is the same as 1 over 3 to the 3rd, which would be 1 over 27. So negative exponents cause us to reciprocate. If your number is in the numerator, it goes down to the denominator. Or if your number is in the denominator, it goes up to the numerator. Like this next one, we'll change this to be 5 to the positive 2, which is just 25. Anything to the 0 power equals 1. Okay, so 7 to the 0 power equals 1. So when it comes to multiples of 10, or in this case 100, when we multiply it to the 3rd power, this will become 100 times 100 times 100. Now, that might be a little hard to multiply. So another way you can think about this is you could change this to be 10 squared to the 3rd, which would be 10 to the 6. Right? So now we know that there should be 6 zeros in our answer. So 10 to the 6 or 100 to the 3rd is 1 followed by 6 zeros. So that's 1 million. And then lastly, so power to power, we multiply them is what we were saying there. And then lastly, if we have two bases with the same base and we're multiplying, we add their powers. So 2 to the 2nd times 2 to the 3rd, we're going to add those. It's going to become 2 to the 5th, which is 32. All right, so just a quick refresher on a couple exponentials and their rules. Let's go ahead and some new stuff. All right, so we're going to talk about solving exponential equations with a common base. So the first thing we're going to do is determine the common base for both sides. So we're going to figure out what can we do to the bases on both sides to make them the same if they're not already the same. Rewrite each side so that they have the same base. You're going to have to do something to rewrite it so it has the same base. All right, and then using your exponent laws, you're going to simplify the powers. So if there's any multiplication or addition, you can go ahead and do that. And then once the bases are the same, then the exponent parts just are equal. So we'll set the exponent parts equal and solve for x. So for this first example that I have here, I have 8 to the x equals 2 to the x plus 6. Now, 8 and 2 are not the same. 8 and 2 are definitely not the same, but I know some exponent stuff, and I know that 8 can be rewritten as 2 to the 3rd. So I asked myself, how could 8 be rewritten as a 2? 2 to the 3rd, 2 can't be rewritten. It's already prime. So that's 2 to the 3rd to the x again, and then this is 2 to the x plus 6, right? So this is 2 to the 3rd to the x. So this becomes 2 to the 3x equals 2 to the x plus 6. All right, since the bases are the same, the tops have to be equal now. So 3x, or the exponents, the powers have to be equal, equals x plus 6. We can just get rid of the base, subtract the x, 2x equals 6, divide by 2, x equals 3. Right? So the goal is to say, looking at my bases, 2 can't get any smaller. 8 I can rewrite as 2 to the 3rd. Multiply those using your exponent rules. Once the bases are the same, the exponents have to be the same as well. Let's keep going. All right, so this one's a little bit different. I have 3 to the x. 3 can't go any smaller. And I have 1 over 27. Now, 1 over 27 is a little bit tricky. I know that since it's a fraction, it's going to have to reciprocate. So I'm going to make that into a negative exponent of some sort. And then 3 to what power makes 27? 3 to the 3rd. So I'm going to rewrite this side as 3 to the negative 3rd. And then this is 3 to the x. The bases are now the same, so the exponents have to be equal. So x has to equal negative 3. All right, so I needed the bases to be the same. This one had a base of 3. I know 3 to the 3rd is 27, but it's in the denominator, so it had to be 3 to the negative 3rd. The bases are now the same, so the exponents were equal. All right, let's look at a couple of these examples here, and then we can keep going. All right, so we'll start with this one. 7 can't go any smaller, but 49 can be written as a base of 7. So this is going to become 7 to the x plus 10 equals 7 squared. That's how we make 49 to the x. Those exponents have to be multiplied, so this becomes 7 to the 2x and 7 to the x plus 10. The bases are now the same, so we can set the exponents equal. X plus 10 equals 2x. Subtract the x, we get x equals 10. There's our answer. All right, our next one, we have 10 to the x plus 2 and 100,000. All right, so 100,000, we can write that as a base 10. So this is going to be 10 to the x plus 2. 10 can't go any smaller. It is not a power of anything. But this 100,000, that is 10 to the 5th power. The bases are now the same, so x plus 2 has to equal 5. Subtract the 2 over, x equals 3. All right, last two problems. The first one here, we have the 2's. We can rewrite those. Those are the same base, so we can add their powers. Sorry, so this could become 2 to the 4 plus x. Be careful there, I almost made a mistake. Don't make my mistake. Since they're the same base, we can add their powers when they're multiplied. And then this other side, this 1, this looks trickier, like 1's smaller than 2. But you have to remember that anything to the 0 power equals 1. So we can rewrite that 1 as 2 to the 0. The bases are now the same, so 4 plus x equals 0. Subtract the 4 to the other side, x equals negative 4 for your answer. All right, and then this last one is probably the trickiest one of these style that I can give you. A couple things to notice. You're going to look at this and you're going to try and match things up. First and foremost, you see that 4 and 25, those are both squares. So I'm going to rewrite those as something squared. 4 is 2 squared, 25 is 5 squared. So I'm going to rewrite that as 2 over 5 squared. And then raise that again to the 2x plus 7. So I simplified that one down first. And I'll distribute this 2 here in just a second. The other one, though, I noticed that the 8 is on bottom. Well, I know 2 to the 3rd is 8, and the 125 is on top, and I know 5 to the 3rd is 125. So I'm like, well, darn, I really wish the 2 was on top like this side and the 5 was on top on this side. Well, I remember that negative exponents allow me to reciprocate. So I'm going to rewrite this one as 2 over 5 to the negative 3, right? Because 2 to the 3rd would be the 8, and 5 to the 3rd would be the 125, and the negative caused them to flip locations. I can then rewrite that to the x power, okay, and I can multiply the negative 3 and the x. So I'm going to get 4x plus 28 equals negative 3x. I just distributed, and I dropped the base because the base 2 over 5 is now the same. I'll add the 3x over, that's 7x. Subtract the 28 over, that's negative 28. Divide by 7, x is negative 4 for our final answer. That one is a little bit trickier. I wouldn't discourage you from maybe rewinding it and watching it again. Checking it out, trying it out on your own would probably be a good idea. All right, with that, you should be able to get started on the homework. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. Until then, have a great day.